So for this, I have a unit circle, and that kind of tells me what my ratios are between them, all right? But now we're going to look at a sine function as putting in an x value and getting out a y value. I'm going to use a example like this. So our first example would be like, without sine, y equals 3x plus 5. We all know how to graph this. What type of graph is this? It's a linear graph. If we did not know that, how would we come up with a picture of the graph? Well, we would pick some x's, we would solve for y, we would plot the points, and we would connect the dots, right? Okay? So now let's look at our sine graph in that type of concept. We have an x, we're going to plug it in, and we're going to solve for y, all right? Specifically, our function here is sine. So let's pull out our unit circles. Look at this particular graph. We're going to start at 0, all right? So if my x value is 0, and I want the sine of x, then what would that be? So that's what we're doing here. So my x value is 0, which means I want the sine of 0. What is the sine of 0?
0.
The sine of 0 is 0. So my point here would be 0, 0. Everybody agree with that? So that's my point, 0, 0. There it is, right there. Okay? Let's do, we're a third of the way, so we'll do 30 degrees. Since theirs is in degrees, sine of 30 degrees is 1/2. So my point here would be 30 degrees, 1/2, right? Which is going to be right here. Okay? Everybody see what we're doing? What about 90 degrees? Sine of 90 degrees is 1. And lo and behold, my graph here would be 90 degrees, 1. So my x value is the angle measurement, whether it is in degrees or whether it is in radians, okay? My x value is my angle measure. My y value, what they hand me when on the other side of it, is that function, whatever the function is I'm looking for, in this case, sine. So if my x value goes in, let's say, 3 pi over 4, my value that comes out is my sine, okay? And they don't use x. Why do you think they don't use x? You can see that it's starting to develop this curve, right? So from 0 to 180, you will notice that all of your sine values are positive. Well, that makes sense, right? Because from 0 to 180, your sine values are in the first and second quadrant. And they're positive in the first and second quadrant, aren't they? And then in the third and fourth quadrant, from 180 to 360, you can see that your sine values are negative. And then what do you think it happens after that? It starts over, because this is just one big circle, right? So my x and y values will start over, and I loop again, and I loop again. This is a cycle. This is a function that cycles. Your sine value is a function that cycles. So you will have a period, you will have an amplitude, right? You will have those things for a sine function because it is a function that repeats itself, just like the ones you've been looking at in the first sections of this chapter, okay? And it will repeat like that. Now, this is the perfect parent function, so to speak, of y equals sine of theta, your parent function. And think about parent function when we did parabola. Parent function is just y equals x squared, right? Before you did any shifting, before you did any stretching, before you moved it around the graph, that was your parent function. This is what your parent function looks like for sine, okay? This is what your parent function is for sine. So then let's talk about then what happens when we move this from degrees to radians, all right? Degrees to radians. So let's look at example 2, and we're not going to actually go through the whole graphing of it again, but we are going to look at it on the actual function because the handout that I give you is all in radians. So let's look at this one, example 2, estimating with radians. All right, so we are not used to seeing a function in a graph in radians. We are used to seeing it with 1s and 2s and 3s and 4s. Radians have pi in them. So let's look at this one. That it shows your 1, 2, and 3 just so you can get a visual of where things are. But it actually does a cycle, and if you'll notice, we did 0 to 180, but now we are going from 0 to pi. Okay? Pi in numeric digits, 3.14 rounded. So you can see that it's just past the 3 there. That's where my pi happens. Pi over 2, that should be exactly halfway through. Exactly halfway through. All right? 3 pi over 2 is 3/4 of the way to it. And I kept going all the way over here, I would get to 2 pi. All right? But you'll notice my sine graph does exactly the same. We go up to 1. Why? Well, that's my highest value of sine, right? It goes down to -1. That is my lowest value of sine on the unit circle, okay? And it does the same cycle. It's just showing it to you in pi over 2 and pi over 4. All right, so let's look at your handout here. What I've given you at the top here is the standard form of a sine function and a cosine function. All right, so if you think about when we've done functions in the past and we shifted them around, let's talk about like a parabola, all right? Remember we found the midline, which was your axis, -b over 2a, right? And then to find your vertex, you plug that in, and then your y-intercept is 0c. Like there's some little key things that happen in the function of a parabola that will help you figure out how to graph the parabola, all right? And so that's what's going to go on with this sine and cosine. We're going to have a standard form of the graph, and then we're going to see what happens when we start changing it a little bit, stretching it, making it wider, or shifting it up and down, or left and right, okay? And so this is the standard form of a cosine function. We have just seen like cosine of 30, sine of pi over 4, things like that, all right? And so now what we're doing is we're going to take those numbers and we're going to plug them into a graph. And then we're going to see how this helps us move that graph around. But before we do this piece, we're going to actually look at the graph itself and what happens when we put it down as a function. All right, so let's look in our books under sine function. So you're going to be given some sine functions, and they want to find the amplitude. Remind me again what amplitude is.
How far do you go away from?
Right, away from your middle point. All right, away from middle point. And so the amplitude for these functions is actually going to be the number that happens in front of your function. Actually, all right, so A here. A is the number that is in front of my function. All right. So if you have a number in front of your function, that is how far away from the middle it's going to go. And so in this case, your amplitude would be A. And the middle of these graphs is called the midline. Midline. All right. In this case, we're not moving it up and down yet. We'll do that in the next few sections. So in this case, it's just going to be your axis, how far away from your axis you get. All right. There's actually something that affects your period here. And the number that affects your period is the number that is in front of the x. All right. So if you have no number in front of your x, it's just going to be 2 pi. But if you do have a number in front of your x, your period is going to change. All right. And so it's actually a formula. Think of it kind of like when we did your axis. You're going to take that 2 pi and you are going to divide it by the absolute value of that number in front of x. So it's 2 pi over the absolute value of b. 2 pi over the absolute value of b. And that is your period. And your period is how long it takes for the graph to complete one cycle. One cycle. All right? So 2 pi over the coefficient of your x. The coefficient of your x. My graph does for a regular sine. We're going to do it without the shifting and without the amplitude. For a regular sine graph, it takes 2 pi to cycle, right? And my amplitude is up, goes all the way up to +1 and down to -1. So my amplitude is 1, right? That's a standard sine graph. So I'm going to show you kind of a shortcut in how these graphs work, all right? So let's start with 0. What did we say my sine value is at 0? 0, okay. What is my sine value at pi?
0.
My sine value at pi. 0. And then what's my sine value at 2 pi?
0.
0. Okay. So if I pick those 3 points, does it help me with this graph?
Yes.
Really? You can see what the graph's going to look like with those 3 points? No, you cannot. All right, so let's do my in-between points. Let's do halfway in between 0 and pi. What's halfway in between 0 and pi?
That's
Pi over 2 is halfway in between 0 and pi. All right, what's my sine value at pi over 2? 1. Let's do halfway in between pi and 2 pi.
3 pi over 2.
That's 3 pi over 2. And what's my value there?
Negative
-1. Now, does it start to show me a picture of what this graph's going to do?
Yes.
Yes, it does. All right. And so that's how we're going to graph these. We're going to graph these using our starting point, our 1/4, our halfway, and our 3/4, and our ending points. Okay? That's what we're going to do. So you figure out where you start. You figure out 1/4 of the way through, half of the way through, 3/4 of the way through, and the ending. Now, let me tell you something about the sine graph. At the start, at the middle, and at the end, it's always going to be at the same point. Okay? So at the start, at the middle, and at the end, it's always going to be at your midline, wherever that is. And in this case, for these problems, that's always going to be your x-axis. All right? 1/4 of the way through, it is going to be at your highest point, your amplitude, the highest point. So the furthest away from the midline, you're going to be up. And 3/4 of the way through, it's going to be at your lowest point, also your amplitude, but down, okay? Your sine graph will always follow these rules. Start, middle, and finish, always at your midline. 1/4 at your highest point, 3/4 at your lowest point, all right? The only time that would change is if we did like a negative and it reversed, but we're not going to do those this year, all right? So this is what your sine graph will always look like. It will always be start, middle, finish, 1st quarter, 3rd quarter. And then you're going to do your curve, all right? But your amplitude and your period may change, which means your starting and your ending point may change, right? If my amplitude is 2 pi, this is what it's going to look like. But if it's 4 pi, my starting point is going to be 0 and my ending point is going to be 4 pi. And my halfway is going to be 2 pi, right? And so you have to find your quarters in your start to end. And that's what we're about to do with this graph right here. So let's look then at this cycle here. One cycle then of 1/2 sine of 2 pi. 1/2 sine of 2 pi. Now, they specifically want this graph. So we're going to do find our amplitude and we're going to find our period. All right, so look at your sheet. Amplitude is your A value, right? Your amplitude is your A value. Which one is your A value here? 1/2. All right. What does that mean? Well, that means we are going to go up to 1/2 and down to -1/2 because our midline right now is the axis. All right. My period. Well, my period is a formula. What's the formula for my period? 2 pi over the absolute value of b. And b is the number in front of my variable, right? So what is the number in front of my variable? 2. So 2 pi over 2. So my period here is pi. All right? And so now we're going to do this particular graph, but we are going to graph based on the information we now have. All right? All right, so we're going to do this, and we're going to graph this function right here. All right, so let's erase our original function. That doesn't get in the way. And we're going to do a new starting point, a new ending point, and new quarter points, all right? So what is my starting point? Still something, right? Still the same thing we started with. Here's my starting point, right? My period determines my ending point. My period tells me when it cycles. What's my period? Pi. So that means we're going to complete an entire cycle in 1 pi. So my ending point is going to be right here, all right? So then where's my halfway point of this? Pi over 2. Where's my 1/4?
Pi over 4.
It's going to be pi over 4. And where's my 3rd quarter?
5 pi. Oh, wait, never mind.
3 pi over 4. So this entire cycle is going to happen right there. All right? My amplitude, I'm not going to go all the way up to 1. What am I going to go up to?
1/2.
I'm going to go up to 1/2. And I'm not going to go all the way on to -1. Where am I going to go to? -1/2. So we're going to graph. All right, we're going to start at 0. 1/4 of the way through, I should be at my highest point. So at pi over 4, where am I going to be? 1/2. Halfway through, I'm going to be at my middle. Where's my middle? Pi over 2 is 0. 3/4, I'm going to be at my lowest. Where's my lowest? -1/2. And at my ending, I'm going to be back at 0, which is where? And then here is my little graph here. All right, he's beautiful, yes. All right, and so you can see we have a much smaller graph. It's squished, right? It's cycled faster and it didn't go as high, all right? That's what happens when you change the amplitude and the period. You change how long it takes for it to cycle and you change how high it goes. However, when you're graphing it, start at your starting point, figure out your ending point, which just means add your cycle to your starting point. Then mark your halfway and your quarters, and then you're just going to do the same cycle. You're just going to do the same cycle here. All right, so I want you to try one of these. I actually want you to try B. 3 sine of pi over 2 theta. All right, let's go over these. Amplitude. What's the amplitude of this? 3. So that means I'm going to go all the way up to positive 3 and all the way down to negative 3. Okay? Period. Period is going to be 2 pi over the absolute value of what? Pi over 2. All right. So, in this case, I have 2 pi times 2 over pi, right? Which means what happens here? The pi's cancel, and I have just 4. Yes? Everybody agree with that? Right, and I actually going to change this from pi because it'll be a little bit easier. All right. So my period is just 4, right? Point here. My starting point is going to be 0. Now my ending point, because my period is 4, is going to be 4, right? You just take your starting point and add your period. My ending point is going to be here. What is my halfway point then? 2. It's right there. What's my first quarter? 1. And I'm going up to what point at 1? 3. What's my third quarter? And I go down to? -3. Your graph should have looked something like this.